Alright, hello and welcome back to Quinn's Wonderful Woodworking. Today we're going to be cutting this into a piece of wood that no one ever asked for or even wanted. Alright, before we get started, there's a few helpful tips that you'll need to remember while cutting wood. The first one is, safety is number 2 priority. Number 1 priority is doing this as quickly as possible. Second tip, this goes back to the first tip already. Remember, don't wear any safety glasses or any gloves. Wear it like this. If you have glasses like this, you can feel free to take those off, or you can just keep them on. It's up to you whether you have good vision or bad vision. Personally, I prefer to cut with bad vision. Alright, so tip number 3. This one's important. This is if you really want to go the extra mile. Make sure no one knows where you are or what you're doing. Now, this tip is really for if you're trying to collect on life insurance. I swear it works every time. Alright, so let's get started. Let me just take a moment to say that straight lines, if you want to cut a straight line, don't worry about it. As long as it's close enough, you'll be fine when you're cutting. So just guess. I personally prefer, hold on, let me just adjust this for you. I personally prefer using a tape measure like this and then just using this as my straight edge. It might be nowhere near a right angle, but hey, it's close enough for me, so it's close enough for you. And we're just gonna take that. Oh yeah, beautiful. That is absolutely gorgeous. Then we just do that the same on this side. Let's see. Bam. And we are done. Ta-da! Okay, now normally at this point, you'd want to sand down these edges because they're kind of rough and maybe they could cut you. You don't want to get any of those splinters, right? Well, here in Quinn's Wonderful Woodworking shop, we don't do that. See, these rough edges here, they add character. They build up what this robot is going to be about. And that's why we do not sand in Quinn's Wonderful Woodworking shop. Okay, so this piece of wood right here is actually going to be the logic board for the self-driving car. So right here, I've kind of got arranged where I want all the components placed. And yesterday, I spent about an hour hunting down a store that would sell motherboard standoffs like these. These took for freaking ever to find, and they were like $7 for 15 of them, which is kind of ridiculous. When I got home and found out these screws that match them are a little too big for the holes that they're going in here, right through this PCB, I'm like, you know what, I don't really feel like going out and buying a different version that's a little smaller for all of this. So instead, I just did what every reasonable, rational person would do and forced the screws in through the PCB, and everything has turned out fine anyways. We're gonna get started drilling some holes here. We've got our wonderful, wonderful little drill right here. We got our drill bits, screwdrivers, everything, and I think we're ready to rock. So obviously this needs some work. I only have one bolt in there right now and you can see it wobbles around a lot. But for now, this should do just fine. I'm thinking later on we'll probably put in a longer and bigger bolt right here with a couple of spacers so we don't have that wobbling issue like we do right now. Okay, so the project board is done. You might notice a distinct lack of the tiny chip that was here before. That was a 3-axis accelerometer and gyroscope. I messed up when mounting it, and one of the tiny SMD soldering parts came off. So that part won't be included for now. I might come back later buy another one because they're only $5 a pop. But for now, we'll be going with this accelerometer and gyroscope. Okay, so the next step is going to be wiring up the battery to the motor via the motor controller, and having a quick release connector so you can get the project board on and off whenever you want. So to do that, I actually like this plug system they have right here, so I'm going to keep that. I'm actually going to just snip these wires right here and keep this plug and as much wire as possible back here. So let's get to work. Cha-ching! Before I forget, I'm also going to cut this connector too, because I'm also going to use this as well. And just for good measure, we're also going to cut these wires. Alright. We're also going to cut these two wires that are leading off of the connector to make sure we don't get any shorts or anything else while we're wiring this thing up. So let's just go ahead and voila. So the next step with these connectors is to cut them to length and strip them so they can be put in the motor controller. We're going to try to preserve as much length as possible so we have more flexibility later on if we want to do more modifications to them. This thing just fall apart on me? It did. Hold on. Well, my wire strippers kind of fell apart on me. You can see the spring right here that would go right here, so it would return back to normal. So for now, I'll just do it like this because I don't want to go out and buy some more wire strippers, but that really sucks. Alright, this will be the side for the battery. So that gets stuck into this terminal right here. Okay, so the next step will be to mount the power distribution, which is going to be this right here, and the 5-volt regulator, which is going to power the Raspberry Pi right over here. Let's get started with that. Okay, so you've seen this in the background of a lot of the shots recently. Might look like a bomb, but don't worry, it only explodes if you mishandle it. I actually built this out of 3 laptop batteries that I got from my school's IT program. I actually worked on repairing laptops for the students all year last year, and we'd always have broken batteries that'd come in because they failed for whatever reason on the circuit board, but the cells themselves were just fine. So I took those, wired them up to this. It's a quick disconnect right here, and that actually feeds into a battery controller and balancer right here. This prevents the circuit from over discharging, from short circuiting, and it makes sure all the cells are balanced so you don't get any of the cells exploding on you. Now you see this case right here. If you look at it, it's actually 3D printed. This thing I designed about a year ago before I even had these cells even wired up or anything like that. And I didn't really think about how you're going to mount it. I just put like this little flange back here. So I'm going to probably make a V2 of this. But for now, I can't really mount it any other way than the best thing in the world, and the thing that fixes everything, some duct tape. If it doesn't work, I'm not using enough duct tape. Just stick that on like that. I don't really care about the wires too much as long as they're not shorting out. They're all well insulated, so there's at least that. There we go. That's how that's going to be mounted for now. Just like the robotics team. Alright, and we're going to finish wiring up the 5-volt regulator to this, and then I think we're ready to give it a test. So we'll start on that. Okay, while I do have a Raspberry Pi on this board, and that will be the final brain of the project once I'm done, I still haven't gotten the network configuration set up so I can connect to it via a laptop to control it. For now, I'm going to do the motor test with this Arduino right here, which is actually running off of the Raspberry Pi's 5-volt output from the USB port here. So when I plug this back in, it'll reset and turn on the motor for 10 seconds and then turn it off again. And it'll wait. I put the delay in somewhere around 31 years, so it shouldn't turn it back on anytime soon. Let's plug this thing in and we'll try that out. So I'm about to plug this thing, unplug it and plug it back in to activate it. Hopefully everything's wired up correctly and I aimed it in the right direction so it doesn't hit the sawhorses over there. And let's try this out. Anything? Want. Okay. Well, first test didn't succeed, that's fine. Oh, Jesus. Well, that did something. Let's try that again. Huh. Interesting. Okay. So, the motor controller works. I'm not sure what's going on with the Arduino itself. Let's get you a better shot of what's going on. Okay, so I'm about to press the reset button on the Arduino, and you can watch. It turns on and off again 3 times and then just stops. Let me go double check the code on the Arduino and come back and see if that fixes it. So I just tested it out after the code change, and it works now. Check this out, because I think it's absolutely hilarious. So let's just... Bam! I just love that. That is great to watch. So that's going to be the end of the video today. Next time we're going to work on steering. As you can see, it's kind of going around in a circle right now. So that means we're going to install a new servo motor we got. It's 33 kilograms per centimeter for torque, which is pretty great. It's absolutely huge. I'm really looking forward to that, and I'll see you guys next time.